Let's talk a little bit about the phase difference between the driver and the resonant masses, okay? Notice that my period is 1.6, so that's going to be the period of this thing. And this is going to be a sine, so there it is at 0 degrees, and you'll see it rotate through, right? When it's here, it's exerting no force on these. When it's up there, it's exerting an upward force. When it's to the left, it's zero force. When it's down there, when this paddle moves down, it's exerting a downward force, and it just goes, it varies like that, right? Obviously, this one's amplitude is going to be the largest because it's going to resonate. It's at the same period, right? These are faster oscillators and these are slower oscillators. And it's important that you know the difference in phase between the driving phase and the fast ones, the driving phase and the resonant one, and the driving phase and the slower one, right? So I'll explain what phase means here. You're like, huh? All right. So here, let's run this thing. Let's get it all worked up here, which happens around like 2000 frames here. We're at about 1,000 right now. I think around 2000, we're about 1400, 1500 frames. Here we are. Okay, around 2000, this thing's just, in full swing. So let's stop it here. Okay, and let's just take a look at this thing. Okay, the first thing I want you to notice is that these things, these faster ones, are in phase. They're moving at the same time. So notice that this guy's down. I'll show you. These guys are down. The driver is down. Now watch. I'll rotate it till it's up. Watch. This must be amazingly exciting for you there at home. Okay, now watch. When the driver is up, when the driving phase is 90 degrees, these fast ones, especially the fastest one there, right? It's lockstep. It's in the phase. That one's up, that one's up. So watch. Watch this and watch this particular one right there. They'll stay in phase. I'll keep running it. Down, up, exactly in phase with the driving phase. So oscillators that are faster than the driver stay in phase. And that's because they're, what? Um, I don't know why that is. It just is, right? They want to oscillate faster, so I guess they just stay in phase. That's not a very good explanation, is it? Okay. Now, take a look at these oscillators over here. Notice that these are exactly backwards. When that thing is down, they're up, and when that thing is up, they're down, right? Do you see that? I'll show you. Let's stop it. Okay. Okay. The driver is down. Hold on, hold on. The driver is down. That one is up. Look, the slow one is up when the driver's down. Now watch, when the driver is let's see if I can run it and stop it. When the driver is up, oh, I almost did it. When the driver is up, that guy's down. This guy is always in the opposite side of the origin, right? That guy's up, this guy's down. Okay, so watch that. Just watch. That guy's up, right? These guys are always in opposition. It's definitely opposite that one, right? Now, the resonant one, this guy's moving so fast, it's hard to see what it is. So let's take a look at that. Okay, so let's start with the driver. The driver is now at 0 degrees, right? This guy is at 270 degrees, right? So he is all the way down. It's like his paddle is all the way down, right? But this guy is at 0. So this guy is 90 degrees behind this guy. Now let's crank it forward until it reaches 90 degrees. Well, notice that our resonant one, the one that's moving the fast, the 1.6, okay? This guy's at 90, this guy's at 0. He's starting another cycle again, right? You start the cycle at the origin moving upward, right? Okay? And now watch. When we are at 180, this guy is at 90. The resonant one is always 90 degrees behind. Okay, now I'm going to move myself to 270. 270, he's at 0, right? He's at 180, sorry. He's at 180 because he's coming through. He's going through the origin going down, not going up, right? So that's 180 degrees, right? And then again, we can go back to 0. So I'm just going to hit run. Now watch how this guy lags 90 degrees behind. Okay? Now I think I know the reason why this one does that. Okay? I can explain this. Okay, let's see if I can stop it. There we go. Notice, let's just look at this thing here, right? Right now we're exerting the biggest upward force we're going to exert, and this thing is right at the origin. So that's the maximum way to give it energy. That is, there's no opposing force on it when it's at the origin, right? And so we can pump as much energy into it as we can. So this optimizes the energy transfer between this doohickey and that doohickey. All right, this has been a very long and boring video, and if you got to the end of it, you should pat yourself on the back. I'm just going to let this thing run, and then I'm going to hit F10 while it's running. Whoa, baby.